In the previous lesson, we went over how to solve absolute value equations. In this lesson, we'll take it one step further by going over how to solve absolute value inequalities. Now, the steps for solving absolute value inequalities are actually very similar to equations with an extra step or two. So let's jump into it. In exercise 2, we're asked to solve the absolute value inequality. The absolute value of m plus 2 is less than 11. And so our very first step is actually to turn this into an equation of sorts, which means that we're just going to rewrite the question, but instead of an inequality, we're going to use an equal sign. So we have the absolute value of m plus 2 is equal to 11 instead of less than for now. Our second step is to isolate the absolute value bars if needed. But in this case, the absolute value bars are already by themselves, so there's nothing for us to do. And now that the absolute value bars are isolated, we can then use the definition to create our two cases. Recall that that means we have the positive case, so whatever is inside the absolute value bars. So in this case, what is inside the absolute value bars? It's m plus 2. And so that will be equal to 11. And then in our second case, we again take whatever is inside the absolute value bars. So what's inside the absolute value bars? M plus 2. But this time, we take the opposite version. So we stick a negative sign in the very front, and that's equal to 11. And then now that we have our two cases, we can go ahead and solve for m. So for the first case, we will simply subtract 2 from both sides, leaving me with m is equal to 9. And then for the second case, we'll divide everything by negative 1. Which leaves me with m plus 2 is equal to negative 11. And then we'll subtract 2 from both sides, which gives us m is equal to negative 13. So far, it's been just as if we've done an equation. So here's where things are going to be a bit new. Okay, first we're going to create our graph. And then we're going to draw at 9, we'll have a circle, and at negative 13, we'll have a circle. Now in this case, notice that I'm choosing to leave the circles as open, because in the original problem, we did have a strictly less than inequality, which means that we need open circles at 9 and at negative 13, not filled in circles. Secondly, we are now going to look at the graph. Notice that there's essentially 3 sections of the graph. We have the section of the points that are to the left of negative 13. We have the section of the points between negative 13 and 9. And then we have the section of points that are to the right of 9. And because we are actually dealing with an absolute value inequality, what's going to happen is if one of the points in these quote sections are true, then all the points in this section are going to be true. So what we can do to solve this inequality is we're going to take any point in the section and then we'll plug it into the original problem and see whether it's true or false. If it's true, then we'll shade that section in. If it's false, we'll leave that section alone. So let's go ahead and do the leftmost section. Okay, I need a number that is less than negative 13, right? A number to the left of negative 13. It doesn't matter what number we pick, so I'm going to go ahead and go with negative 15. So I'm just going to test x equals to negative 15. Right? It doesn't have to be negative 15 specifically. It just has to be a number that is to the left of negative 13. And so we'll plug that into our original problem. The absolute value of negative 15 plus 2 is less than 11. Okay, well, this is the absolute value of negative 13 is less than 11. Well, the absolute value of negative 13 is 13, right? Because negative 13 is 13 away from 0. And this is false. So we are not going to fill in this leftmost section. Okay, now let's test this middle section. We'll test x equals to 0, right? Again, it doesn't have to be 0. It just has to be any number between negative 13 and 9. So we'll take the absolute value of 0 plus 2 is less than 11. Well, 0 plus 2 is 2. So this is the absolute value of 2 is less than 11. And the absolute value of 2 is, well, 2 is 2 away from 0. And this is true. And so because this is true, we're going to fill in this middle section. And then lastly, we have this rightmost section. And so we need any point to the right of 9, or any point that is bigger than 9. So we'll test x equals to 10. So we have the absolute value of 10 plus 2 is less than 11. This is going to be the absolute value of 12 is less than 11. And the absolute value of 12 is 12. And saying that that is less than 11 is false. So we have only this middle section that is filled in. And so what we can do now in our final step is we're actually going to write a compound inequality to represent the solutions. Remember, the way that we do that is, where's the shaded region? Well, our shaded region is strictly greater than negative 13. And then our shaded region is also less than 9. And so that is our solution. It is negative 13 is less than x, which is less than 9. So again, notice that it's pretty much identical to solving an equation. In fact, we turn the problem into an equation. And then once we've turned it into an equation, we solve for the 2 points. And then the 2 points will create intervals or sections of the number line. And then we test 1 point in each of those sections to see if it's true or false. And then based on whether it's true or false, we shade in that entire section. And then once we have the number line, we can then write a compound inequality. Let's go ahead and move on. So here we're asked to solve 3 times the absolute value of 2x minus 1 is greater than or equal to 21. So our first step will be to turn this into an equation. So we have 3 times the absolute value of 2x minus 1 is equal to 21. And now that we have our equation, we'll go ahead and isolate the absolute value bars, which we'll do by dividing both sides by 3, leaving us with the absolute value of 2x minus 1 is equal to 7. And now that the absolute value bars are by themselves, we'll use the definition to create our 2 cases. So we have whatever is inside the absolute value bars is equal to 7. And then we have the opposite version of whatever was inside our absolute value bars is equal to 7. Now we'll solve for x. So for the left equation, we'll add 1 to both sides, leaving us with 2x is equal to 8. And then we'll divide both sides by 2, giving us x is equal to 4. On the right equation, we'll divide both sides by negative 1 to give us 2x minus 1 is equal to negative 7. We'll add 1 to both sides to give us 2x is equal to -6. And then we'll divide both sides by 2 to give us x is equal to -3. Okay. Now that we have our 2 points, we'll go ahead and create our number line. So we have a point at -3, and we have a point at 4. And for this problem, because the inequality in the original problem had the equals part, we do want to fill in these circles. And now that we have our 3 sections, we'll go ahead and test a number in each section. So for the leftmost section, I'll use I'll test x equals to -4, because that is a number that is to the left of -3. So we'll plug that into our original problem. So first, we'll multiply the 2 and the -4 to give us -8. Then we'll subtract -8 and -1 to give us -9. Well, the absolute value of -9 is going to be 9. And then 3 times 9 is 27. And so we have 27 is greater than or equal to 21, which is true. So we'll shade that section in. Now we need to test the middle section. So I'll test x equals to 0, because 0 is between -3 and -4. So we have 3 times the absolute value of 2 times 0 minus 1 is greater than or equal to 21. 2 times 0 is 0. Then 0 minus 1 is -1. And then the absolute value of -1 is 1. And then 3 times 1 is 3. Well, here I'm saying 3 is greater than or equal to 21, and that is false. So we will not shade that middle section in. And then we have the rightmost section. So here I'll test a number bigger than 4. So let's go with 5. So again, we'll replace x in the original problem. Then 2 times 5 is 10. And then 10 minus 1 is 9. And then 3, the absolute value of 9 is 9. And then 3 times 9 is 27. Here I have 27 is greater than or equal to 21, which is true. And so we'll shade in this right section. And now that we've done that, we can write our inequality, and I'll just do that above. So here I have the shaded section x is less than or equal to -3. Here I have this gap, so we'll use the word or. And then we have our shaded section x is greater than or equal to 4. And so there is our solution. Again, notice that the steps was to 1, turn the original problem into an equation. Then once we had an equation, we split it into 2 cases after getting the bars by themselves. After that, we created 3 sections on the number line, and then from there we tested the points to then create the graphs. And then with the graphs, we wrote a compound inequality. Now I'm going to skip exercise 4, and in exercise 5, I'm going to leave it to you to approve, But as it turns out, in exercise 5a, once you solve it, you're going to find that there are no solutions. And then for exercise 5b, you're going to have infinite solutions. We can go over that in class when I come back, but I do want to keep this video to shorter, so we'll stop there.